In this video, we're going to talk about how to graphically display a quantitative variable. So first, let's talk about common graphs that we use for quantitative variables. There are definitely more than what we're going to cover, but the two that we will cover are called histograms and box plots. So first, let's actually look at these graphs in StatCrunch. First, you'll also notice I provided them here for our PJA earnings data set that we're working with, but I know some of it's a little blurry here and hard to read. That's also why I want to construct them here out in StatCrunch. So I did not put specific directions for these because I think that they probably go pretty easily. So to get a graph, I'm just going to choose the graph option. For a histogram, we'll choose histogram. For the box plot, we'll choose box plot. So for the histogram, I'm just going to click that, say which variable I would like. So I'm going to just use earnings. You can put on titles, as you can see that I did in the actual handout, and then just hit compute. So here is our histogram. One option that sometimes is nice is to put the value above the bar. So it'll tell you how many people fell into each option. So we had 118 people make between $0 and $1 million. We had 49 people earn between $1 and $2 million, 15 between $2 and $3 million, and so on from there. To get the box plot, again, we just go to Graph, Box Plot, select the variable that we want. I prefer to draw my box horizontally, and notice I also uncheck this box to identify outliers. That's the only way your graph will match mine. So then if I hit compute, I get that box plot. Now, if you remember when we first talked about numerical displays, we talked about the 5-number summary, which is used to create a box plot. So there's actually 5 numbers on the box plot, and you can kind of see them here as I hover over. So we're going to use the min, Q1, the median, Q3, and the max. And that IQR is just something they calculated, which is the width of the box. But so where those 5 numbers show up is this far number on the left here is the minimum value. The far number over here on the right is the maximum value. Then to create this box is where the other 3 numbers come from. We have our Q1 is the outside of this part of the box. Q3 is the outside of this part of the box. So it goes from Q1 to Q3. And then the line is at the median. So those are our 5 numbers on the box plot. Again, I know it's a little bit harder to see here, so I'll kind of draw over it. So we can also label. There's what our box plot looks like. So again, this value far over here on the right is our max. On the far left here is our min. Q1 and Q3 are used to create the outer part of the box, and the line in the middle is the median. So these two graphs are displaying the same type of data, just in different ways. So it's the exact same values, just in 2 different ways of looking at it. So here I can see again, so right 50% of my data falls between Q1 and Q3. 25% for each spot here, so 25% between here and here, 25% between here and here, 25% between here and here, and then finally 25% between here and here. So there's a much larger spread here because it takes a lot further to get that 25% of the people out that way. So now that we have graphs, what do you do when you have a graph? Like, what are you looking for? So when it comes to a graph, the first thing we're going to talk about is the shape of that graph. And so we're going to go through some different types of shapes. The first one is asking ourselves if the data set is symmetric or not. Now, symmetric is probably one of those words that we all can recognize, but have a hard time describing. So we're having that mirror image on either side. But one thing to note about this is it does not have to be perfect. So it can be close to symmetric, and I might still call it symmetric. So what would a graph look like that is not perfect, but I would still call symmetric? So there's one where, again, it's not all perfectly symmetric, but you can see for the most part it looks pretty symmetric there. The next question I'm going to ask is if my data is unimodal, bimodal, or is neither. So first, breaking this down, so uni is 1 and bi is 2. And then you've probably heard of a mode of a distribution before, or of a data set, which is generally your most common frequent number to show up. Really what we're asking here for is how many peaks does the data seem to have. So it could have 1 peak, 2 peaks, or none, or it could have more than 2 peaks. That's why that neither is there as an option. So I just imagine kind of trying to put a curve over my graph and kind of see how many peaks that one has. And doing the same thing with this other graph. Hopefully we would see the one on the left is a unimodal graph because it only has 1 peak. And the one on the right would be a bimodal graph because it has 2 peaks. But also this first graph I would also call symmetric, and that one actually is perfectly symmetric there for us. The one here on the right, though not perfect, I would probably call this one roughly symmetric. But again, not perfect. The next question I might ask is if my data is uniform. So what does a uniform picture look like? It's going to be actually pretty boring. The data is going to be relatively flat. There's really no peaks going on with it. So no peaks. Relatively flat. Again, not perfect. And it's going to be also pretty symmetric. Next we have if the data is skewed right or skewed left. Generally, students don't have a problem recognizing that the data is skewed, but a lot of times we'll get the direction backwards. So looking at the one here on the left, if I kind of put my curve over it, so first of all, I would describe this as being unimodal because it has just the 1 peak to it. But to figure out which way it's skewed, I always imagine that it's a slide. So if I climb up the slide, which way am I going to slide? I'm going to slide to the left, which means that this one is actually then skewed to the left. So it's which way you slide. Versus the one over here on the right, I go up my slide and I would slide to the right. So I will call that one a skewed right graph. I can also see that this one also only has 1 peak, so I would call it unimodal as well. So how shape is important is going to tell us how the mean and median will compare based upon that shape. So remember, mean and median are our 2 measures of center that we discussed. So if a graph is pretty symmetric, what's going to happen is the mean and median will be close to the same value. So there will really be no difference in your measures of center if the data is symmetric. However, as soon as you are skewed, that is no longer true. If you are skewed to the left, what that's going to mean for us is that the mean will be quite a bit less than your median. So the mean is going to get pulled in that direction of the skew. Kind of imagine if you think about looking at test scores, and then if there's students that got that 0, it's going to pull down that mean closer to them. A skewed right graph will have the opposite happen. The mean will actually be quite bigger than the median. An example that fits into this is generally salaries at a company, that generally most people aren't making the big bucks, but only a few people are making those large amounts of money. But then the mean will get pulled up once you start factoring in those millions of dollars that some people seem to make. The last thing I can look at with a graph is just outliers, which are just points that don't seem to fit the pattern of the rest of the data. So let's look at our graph that we had here for our PGA golfers. So how would we describe its shape? Well, it's definitely not symmetric. It is actually definitely very skewed. Which way is it skewed? Well, we're sliding right, so it's going to be skewed to the right. So it's not symmetric if it's skewed. It's also not uniform if it's skewed. Is it unimodal or bimodal or neither of those things? Well, again, for this one we just have one overall peak, so I would describe this one as being unimodal. Now, are there any points that don't seem to fit the pattern of the rest of the data? I have this person over here on the far right that made over $8 million, and that's far away from most of the data and stands out like a sore thumb. It especially stands out because we have this big gap where there's nobody right there. So because of that gap and this point just kind of all by its lonesome, I will call that an outlier. In the next video, we're going to summarize all of these things that we've talked about in the first 3 videos with one big example.